Rhombi, rectangles, and squares. Three special parallelograms. All of the properties of a parallelogram apply to the rhombus, rectangle, and square, so these figures are special parallelograms. A rhombus is a quadrilateral with four congruent sides. If AB is congruent to BC, is congruent to CD, is congruent to DA, then ABCD is a rhombus. Note, ABCD is a parallelogram too, because its opposite sides are congruent. So a rhombus is a special parallelogram. A rhombus is a parallelogram. The diagonals of a rhombus are perpendicular. The diagonals of a rhombus dissect the rhombus into four congruent right triangles, 1, 2, 3, 4. Each diagonal of a rhombus bisects two angles of the rhombus. Here's a two-column proof. Let's go through it together. Given that ABCD is a rhombus, prove that AC is perpendicular to BD. Alright, so we begin with our given information. Since it's a rhombus, the sides are all congruent. AB is congruent to BC, which is congruent to CD, which is congruent to DA. The diagonals are also congruent to themselves. AC is congruent to AC, and BD is congruent to BD. Because of that, we have side-side-side triangle congruence. Triangle ABD, this triangle here, is congruent to triangle CBD, this triangle here, due to the shared side here and the congruent other sides. Now, because of the Isosceles triangle theorem, we know that angle 1 is congruent to angle 4, since this is an isosceles triangle, since these two sides are congruent. The base angles are also congruent, and they're also congruent with these angles here. And because corresponding parts of congruent triangles are congruent. For the same reasons that this just worked, we can repeat that here. Triangle DAC here. First I will go and erase some of the markings I've just made. Alright. DAC, so this triangle is also congruent to triangle BAC here, because of side-side-side triangle congruence, since this diagonal here is congruent with itself and the other sides are all congruent. Therefore, angles 2 and 3 and 6 and 7 are all congruent because of the isosceles triangle theorem, and corresponding parts of congruent triangles are congruent. Therefore, if I'm just going to erase some of these lines to make room. Alright, so since angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3, we can see from the third angle theorem that angle APD here is congruent to angle APB here. Since the other two angles in these triangles are congruent, therefore the third angles are also congruent. And two lines that form congruent adjacent angles are perpendicular. So AC is perpendicular to BD.